So we are studying the Mann's reaction. So you can see that Mann's reaction is an amino alkylation reaction. Okay, what is amino alkylation reaction? Means amine group will be having the alkyl group. That is the amino alkylation. Means there is a addition of alkyl group to the nitrogen of amino functional group. It involves the condensation reaction. When we are talking about the condensation reaction, means there is a removal of water molecule. So it involves the condensation of enolizable carbonyl compound. When I am saying enolizable carbonyl compound, means it is having the alpha hydrogen. Now next, with a non-enolizable aldehyde. When I am saying you are having the non-enolizable aldehyde, means it is not having the alpha hydrogen. Like you are having the formaldehyde. Formaldehyde is not having the alpha hydrogen. And ammonia or a primary or secondary amine. So all these things means first you should be having the enolizable carbonyl compound. Second, you are having the non-enolizable aldehyde. Third, you will be having the ammonia or primary amine or secondary amine. All these three compounds will undergo condensation reaction and they will form the beta amino. They will form the beta amino carbonyl compound. That beta amino carbonyl compound is also known as Mann's base. Okay. So this is the statement for the Mann's reaction. So in Mann's reaction, you have to remember it is amino alkylation reaction. Means nitrogen of amine functional group will get alkylated. Means there will be addition of alkyl group. This reaction involves three compounds. One is enolizable carbonyl compound, second is non-enolizable aldehyde, and third you are having the this ammonia or primary amine or secondary amine. They will undergo condensation reaction, means there is a removal of water molecule, and you will get the beta amino carbonyl compound, and this beta amino carbonyl compound is also known as this Mann's base. Okay, so here I have given the general reaction. You can see that first it is green molecule is secondary amine. Okay, then you are having the formaldehyde, black color. Then red color you are having the enolizable carbonyl compound. Okay, it is enolizable because you can see that the alpha carbon is having the alpha hydrogen. Red color hydrogen, you can see it is alpha hydrogen. So it is enolizable carbonyl compound. They will undergo condensation reaction. Okay, so when it is going condensation reaction, means there is a removal of water, and you will get the beta amino carbonyl compound. Okay, beta amino carbonyl compound. So why it is beta amino? So you can see that you are having nitrogen. To nitrogen you are having the alpha carbon. To the alpha carbon, then you are having the red color beta carbon. Okay, now this beta carbon is having your carbonyl functional group. So this is why it is named beta amino carbonyl compound. Means beta carbon will have the carbonyl functional group. Is it clear? Beta carbon with respect to the nitrogen will have the carbonyl functional group. So this is reaction for the Mann's reaction. Here I have given one example for the Mann's reaction. So you are having the cyclopentanone, you are reacting with the formaldehyde and you are using the diethylamine. Okay, so diethylamine is secondary amine, formaldehyde is non-enolizable aldehyde, and this cyclopentanone is the enolizable carbonyl compound. So when you are adding the acid catalyst, you will get this beta amino carbonyl compound. So you can see that with nitrogen, whatever carbon is attached is the alpha carbon. Then you are having the beta carbon. To the beta carbon, there is a carbonyl functional group. Okay. So this is the example for the Mannis reaction. So now we will see the mechanism for the Mannis reaction. This is the mechanism for the Mannis reaction. So first, formaldehyde will react with the this secondary amine. Okay. So now you can see that nitrogen is having the lone pair of electron. So means we can say the electron rich. And in formaldehyde, oxygen is electronegative, so it will pull the electron towards itself. So oxygen will be having the negative charge, and carbonyl carbon will be having the positive charge. Okay. So to the carbonyl carbon, this nitrogen will get attached, because nitrogen having a lone pair of electron, means it is having extra electron. It can form bond with the carbonyl carbon. So it will form the bond with the carbonyl carbon, and you will get this structure. Before this, this when nitrogen is forming the bond with this carbonyl compound, at that time nitrogen will be having the four bonding. Okay. Nitrogen will be having the four bonding, like will be having the nitrogen will be having the hydrogen, then it is having 2 Et. Okay. It will be having 2 Et. Now as nitrogen will be getting four bonds, you will be having the positive charge with nitrogen. Now to neutralize the positive charge of nitrogen, proton will be liberated. Okay. Proton will be liberated, as we have discussed in the chapter 3, if you remember. When there is a positive charge to the nitrogen or oxygen, to neutralize the positive charge, one proton will be removed and proton will be liberated. So here also, this nitrogen will form the bond with the carbon carbon, and nitrogen will have the four bonds. That is why nitrogen will have the positive charge. Now to neutralize the positive charge, one proton will be liberated, and that proton will be taken by this oxygen, and it will be having the hydroxyl group. Okay. So this is how you will get this structure by reacting the formaldehyde with diethyl amine. So once you have formed this structure, now you have added the acid catalyst. Okay. Now acid catalyst, this hydroxyl group will take proton from the acid catalyst, and it will form this structure. Okay. Now in this case, oxygen having positive charge and nitrogen is having the lone pair of electron. Now this part will be removed as water molecule. Okay. This part will removed as water molecule. Now as this part is getting removed as a water molecule, and you can see that this bond is breaking, the carbon that you are having will be having only 3 bonds. Okay. Means it will be having the positive charge. So to neutralize the positive charge, lone pair of nitrogen will get transferred between the carbon and nitrogen, and you will be having the 4 bonds around the carbon. So with this you will get this iminium structure. You will get this iminium structure, or you can say the imine structure. So once you have got this iminium structure, now you have you are also having the enolizable carbonyl compound. Here we have added the acetone as a enolizable carbonyl compound. Okay. Now if you are adding the acid catalyst to the acetone, it will form the enol. If you remember, we have studied the enolization, we have studied with respect to the acid catalyst, we have studied with respect to the base catalyst. So when you are adding the acid catalyst, it will form the enol. So this is the enol form of the acetone. Okay. Now you have generated the enol, and you have formed this iminium ion compound. Okay. Now you can see that in iminium compound, in this compound or species, nitrogen having the positive charge. Okay. Now to neutralize the positive charge, whatever double bond you are having, from that pi bond will get transferred to the nitrogen to neutralize positive charge. So when this pi bond is getting transferred, the carbon, this carbon you are having, will get the positive charge. Okay, will get the positive charge because it will be having 3 bonds. So now, as carbon is having the positive charge, this enol that you are having, this enol, in enol you are having the double bond. If it is having double bond, means it is electron rich. So this pi bond will get transferred to this carbon and it will form the bond. So when this bond is getting transferred, the bond that you are having between this O and H will get transferred between carbon and oxygen. Okay, carbon and oxygen. So by reacting these two, you will form this beta amino carbonyl compound. Okay, now this C double bond O is formed, this OH bond has been transferred, and this carbon has formed the bond with this carbon. So now you are having the bond over here, and you are having the this uh, diethyl amino part. Okay, so this is how you will get the beta uh, amino carbonyl compound by using the Manis reaction concept. Okay, so I am again explaining this mechanism. So as you know that statement for the Manis reaction, you should be having 3 components. One is non-enolizable aldehyde. Second, you should be having the enolizable carbonyl compound. Third, you should be having the ammonia or primary or secondary amine. Okay, these 3 things are required. They will undergo the condensation reaction and will form the beta amino carbonyl compound. So here, first step, this non-enolizable aldehyde, means formaldehyde, will react with the diethylamine. Okay, and it will form this structure. Okay, now you have added the acid catalyst, so this OS will take the proton from the acid catalyst and it will form this oxyanion compound, oxyanion species. Now this oxyanion will liberate the water molecule, and as it is liberating the water molecule, means this bond is getting broken. So whatever carbon you are having at this place will be having the positive charge. So to neutralize that positive charge, whatever lone pair of electron you are having with the nitrogen, that will get transferred between the carbon and nitrogen, and you will get this iminium structure. You will get this iminium structure. Now you are having the enolizable carbonyl compound. Here we are having the acetone. So now this acetone is having CH3, means these CH3 are having the alpha hydrogen. So they are enolizable. So when you are adding the acid catalyst to the enolizable carbonyl compound, it will form the enol. So this is enol structure. Okay. Now you have formed the enol. Now this enol and this iminium ion will react, and you will get this beta amino carbonyl compound. So this is the mechanism for the Manis reaction. Okay, so you should be having the 3 component: enolizable carbonyl compound, non-enolizable carbonyl compound, and ammonia, primary amine or secondary amine. Okay, these 3 things in presence of acid catalyst will undergo the Manis reaction, and you will get the this beta amino carbonyl compound.